Okay, number 20, we're asked to show that the line integral is independent of path and then evaluate the integral. Remember, independent of path, it's independent of path if the vector field is conservative, and here's our P and here's our Q. And so I'll define it as F4 equals, so 1 minus y times exp negative x. That's the first component, and then the Q is exp of negative x. Okay, and then let's insert an execution group here. So now we want to see, well, we're supposed to show that it's independent of path. So we know that it has a potential function, but I still need that command. And now we're just back in two-dimensional space. And I'll call the potential function F4. Okay, true. We knew it should be, and I'm going to insert an execution group. And so we want F4. Even though I don't think it has actually assigned this expression to F4, we can try. So if I do subs x equals 0 into F4, let's see what happens. Oh, it did. And then we can, oops. Except this e to the 0, I have to see that, I'm going to do Control K. It should simplify to just be y. Okay, it did. Okay, so it did actually assign it to F4. I'm going to just delete this here. So I need to insert some text. Let's do it here. Actually, let's copy that whole sentence. The vector field is conservative. So the line integral is independent of path. The potential function for 4 is given below. Okay, and then when it says evaluate the integral, remember if it's independent of path and it has a potential function, all we have to do is evaluate the potential function at the endpoints of the curve. We'll do this, plot the vector field separately after I evaluate the function. So we'll do substitute subs. So the last point was x equals 1, y equals 2 into F4 minus, and then we have to substitute the first point in. So I'm just going to copy and paste, and the first point was x equals 0, y equals 1. Semicolon. We'll see. And then we want to simplify that. So Control K, simplify. Okay, because this was 1 minus 1. So Control, actually I'll insert a paragraph before here. Oops, that's not what I want. The value of the line integral, oops, is that. Okay, so that's a positive number. So let's look at the vector field and then the path on the vector field and see if it, because remember f.dr always gives the work, and so if it makes sense that the work we're getting is positive. So I'm going to need a couple execution groups. Oops, I want it actually after. So I'll put my cursor here. Okay, so to plot a vector field, it's field plot, two-dimensional vector field, it's field plot, and then type in the expression for the vector field. So it's, actually, I I don't have to, I've already defined it. I can just plot F4. And let's only use the X and Y values for the range. So the X went from 0 to 1. That's where the points went. Right? 0, 1 to 1, 2. So my X's only have to go from 0 to 1, and my Y's go from 1 to 2. Oh, and if you ever get a command back, that means you need to execute a with command. So I think I need with plots. And then now let's go back up. Okay. And so there's our vector field. And now let's plot the path. So the path is, and I'm going to parameterize it. So the direction vector would be just 1, 1. And so the x would be 0 plus 1t, or x is just t. So we do plot, and then the x is t, and the y is, I think, 1 plus t. Yeah, 1, that's our y naught plus bt, so 1 plus t. And whenever we do line segments, the parameter always goes from 0 to 1. I shouldn't be getting 2. Okay, I need to even have the range in brackets. There we go. So it's going from the x is 0, the y is 1, the x is 1, the y is 2. So I have there, and so now it makes sense because I'm going from here to here. At the beginning, the x's seem not to be going either left or right. So there's the x component of work is 0, but the y's are pointing up and I'm going up. So it's positive work here. And now the x's sort of start to point to the right. And so I'm going with the vector field, so it makes sense that the work done is positive. But now I want to plot them together. So what we do now is once we see that our graphs are right, then we can give them names. So I'm going to call this plot1 colon equals. And it's not going to show the graph after I execute this command anymore. So it's kind of saved it though, and then I'll call this one plot2 colon equals. And then I do display, and then curly brackets, plot1 comma plot2. Close curly brackets, close parentheses, semicolon, enter. And then there's our, there's the vector field and the path. And so you see it's crossing these arrows where the x is not pointing left or right. So we're not, the x does nothing. But then the farther we get to the right, the more we go exactly with the vector field. Okay, and then this one is to be done on your own.